All right, guys, let's get started. So, as we've talked about, we now know how to do saving problems, more realistic ones, where we deposit a bit at a time. But now it's time to live off that money. So, we are going to do a simplified scenario uh, just so that we can actually crunch some numbers and just see how the math works. Um, we understand $100,000 at retirement is not going to stretch very far in this day and age, and $20,000 taking out at a time seems like a lot. More realistically, you might take out a bit every month, but this is just to emphasize what's going on math wise. But yeah, our scenario is this. So Grandpa Simpson has saved up a nice round number, 100,000 for retirement. But while he lives off his retirement savings, that money still continues to get interest. So we don't stop calculating interest, and he gets 10% and it's compounded annually. We're going to track and see when his money runs out. Spoiler alert, it looks like 8 years, but let's see. But we are going to just crunch the numbers today. We are going to hand bomb this table out. So if you're watching at home, you can feel free to just pause the video and try that on your own instead of watching me do it. But I can do the mental math with this one. So Grandpa Simpson has $100,000. He, in that first year, it gains an extra 10% interest. Not bad. So that gets us to $110,000. But then he's starting to live off that money. So he's going to take out 20,000, and we can still use the mental math. I'm not going to do dollar signs just to keep things not too clunky. It's all in dollars here. And then he has 90,000 to start year two with. And we're just going to apply the same rule over and over and over again until Grandpa Simpson runs out of money. We're going to multiply by 1.1, and then we're going to subtract 20,000. Just one time. This is the only time I'll ever make you guys do a table like this by hand, but it's just good to see one time how this works. So 90,000 times 1.1. I could $99,000 becomes $79,000. Then we start the next year with $79,000. I'll try not to speed through it too fast, but I'll just try to match your pace here in the classroom. And again, this is very tedious, but we're only going to do this one time. Well, that may be true. Next week, I might want to use spreadsheet programs to make big long tables like this, but just generate them automatically. But that's just an idea I have. We might not have time. All right, let's continue. Minus 20,000 times 1.1. 73,950. Take away 20,000. 53,950. Times 1.1. 58,949. Take out 20,000. 38,949. I'm just going to pause and check. After year 5, I have 38,949. Okay. Because you guys would just let me perpetuate my mistake and not tell me. Because that's just the kind of people you guys are. Times 1.1. Okay, I haven't had to round anything because we're still in dollars and cents here. $42,843.90. Okay, we're getting close to running out of money here. So $22,843.90 after year 6. Minus 20,000. Multiply that by 1.1. So we can take out the full 20,000 this year. That would leave him with 5,128.29. Before I continue, you guys got that too? Okay. So, yeah, year 7 can take out a full $20,000. Year 8 will be a bit different though. We add on our interest. I do have to round this one. $5,641.12 if we're rounding correctly. So in this last year, Grandpa Simpson cannot withdraw $20,000. He doesn't have that much. We're going to say he withdraws all of it. So $5,641.12. And that gets him to 0. He's done. So he started with $100,000. Can you guys do one thing for me, though? You might not even need a calculator for this, but feel free to use one. How much did he withdraw altogether over the course of these 8 years? He withdrew $20,000 7 times, and then an additional $5,000 and change on the end. That's, 7 times 20,000 is 140,000. So I guess we can just use mental math here. He was able to take out, can I do the mental math? Yes, 145,641.12. I think that's right. 7 times 20,000 plus that little bit. He stretched his money. He saved up 100,000. He already gained a ton of interest while working, making all that interest, saving up his $100,000. But he continues to get interest, and he can stretch that 100,000 out while he is in retirement mode. So hopefully you guys are convinced of the following. So let's I just have 2 conclusions to make, one specific, one more general. Conclusions. So he saved up 100,000, yes, but it's not like he only withdrew $100,000. So Grandpa Simpson was able to withdraw much more than the original $100,000. And the second point is just the more general point. I'll just say this. You can stretch out your retirement savings when you start living off of it. When you start living off of it. So yeah, specifically, we just saw Grandpa Simpson was able to withdraw way more than he had originally saved. But this is the big idea. You have all your retirement savings, but when you start living off it, as long as you don't take it all out at once, it keeps getting interest, and you can stretch it out a whole lot farther. And today we'll see that you can really, really, really stretch it out. It's quite fascinating. So yeah, that's hopefully you guys are convinced. You guys convinced? So then now we're just going to look at our TVM solvers. How do we do these kind of problems in our TVM solvers? How do we go from saving for retirement mode to doing calculations where we're living off our savings? What kind of things can we do? All right. So I think we're doing 4 problems together. And then I might maybe just, as we do a couple of these, play around a little bit. So here's our scenario. So like most people, by the time they retire, kind of know what their lifestyle is and what their budget is and know how much they'll need to retire. So let's say, maybe home is paid off, or maybe I'm living with the kids in their basement or something. I need $3,000 a month to maintain my current lifestyle that I want to live. I know where I can invest my money. We have an interest rate compounded monthly. And in this question, I want to make my money last for 25 years. How much will I need to save up? So in this question, this kind of retirement planning question, we're finding a present value. We know our lifestyle. We know how much we want to take out. Notice here, instead of making deposits, N is the number of withdrawals. It's like a payment, but to ourselves. So N is not years here, it's withdrawals. You guys should be, the things we're doing right now, you guys should be comfortable doing. There's not much really changing from what we did yesterday. So in this scenario, we're making monthly withdrawals for 25 years. 25 times 12, I believe, is 300. So your solvers will do that. A calculator will do that. Interest rate is 6%. So PMT, all right, I want to withdraw $3,000 per month. I am getting that money, so we're going to do PMT as positive 3,000 because I'm getting that money. I'm withdrawing it out. What do you guys think we'll use for FV? I want to make it last for 25 years. What happens at the end of 25 years? Yeah, it's all, Aaron's got it. Pardon me? Takeaway, it's all gone, right? I'm left with nothing. So yesterday we started with nothing and we saved up and had a future value. Now we have that money saved up. We take it away until it's all gone. FV is equal to 0. And this is a monthly problem. So 12 and 12. Yeah, so let's check it out. How much do I have to save up to maintain this lifestyle? Our TVM solver can do this for us. It's a new type of problem, but it's a useful one. I will do it with you guys. 300, oopsie doodle, 6, positive 3,000, 0, 12, and 12. Yeah, 3,000. Seen below. I got over 465,000. You guys get that too? Which is seems like a lot, but remember we showed yesterday that just by saving a little bit every month, we can actually get there. So 465, 620. Where am I? 465, 620. And it was negative because I would have to have that invested. 465, 620, 59. Again, I'm trying to set a good example, so I'll just make a concluding statement. I'm not your dad, though. This is your note. If you don't want to put a concluding statement, nobody's marking it. He would need 465,620.59 saved up, which is a lot. But can you guys determine, so how much did I withdraw over those 25 years? Those 25 years when I was in retirement, just living off that money, $3,000 I withdrew 300 times. Well, how much is that? Well, we can find out. That's not too hard. We made 300 withdrawals of $3,000. How much is that? The number, that's nice round numbers. I think that's $900,000. Which is crazy. That's almost double what we had invested. So not only while I was working did I make a ton of free money and interest by saving regularly, now when I'm retired, I get a whole bunch of extra in this. I almost double the amount of my initial savings by just stretching it out over time. So very fascinating. You guys okay with what we did there? Let's use the same interest as part A. You guys this time choose a monthly budget. Live lavishly. Live what's the opposite of lavish? Frugally? I don't know. But you pick. Or if you're lame, you can just use what I'm going to do. Let's do something different. I want to make my money last for 10 years, but I want to blow through $10,000 every year. I'm not your dad. You guys do what you want. I'm going to do this one on mine. Let's figure this out. So I would do 10 years of monthly withdrawals. 10 times 12 is 120. It's 6%. How much do I need to have saved up? I am blowing through 10K every month till it's all gone. FV is 0. All right, let's do mine. So 120, just doing $10,000. I am not expecting this to last very long. Okay, I would have to have almost $1 million saved up just for this to last for 10 years. For whatever you got, write that down. I got, if you were using my example, I got this. So 900,000, 734. 900,000, 734. 53. I almost was going to be naughty and just say, you know what, I don't need a therefore statement, but I'm going to do it because I'm just setting a good example for you guys. I would need, well, this is you can put he would need. I would need almost $1 million, $900,734.53 saved up. Let's do example 2 together, and then we're gonna, before we do the last one, we're gonna play around with example 2 for a sec. So that was a question where you know what your budget is, you know how long you need your money to save for, like you basically you know when you're gonna die, so you just need the money to last that long, so you can leave nothing to your kids. And then how much do you have to have saved up? Well, we can do a different kind of problem. So in this problem, we know what we have saved up, and we know how long the money needs to last for, so we can calculate how much we can withdraw every month to make our money last. So in this one, we're saying 300,000 is saved up. It's investing, so it's negative. We are going to make the money last for 12 years. Excuse me, 20 years, but it's 12 times per year. So we're going to make 20 withdrawals. Well, we've been doing a lot of monthly. Same account, so 6%, just a new type of problem. 20 years, we're going to stretch this out till it runs out. FV is 0 for these kind of problems, 12 and 12. So yeah, one more thing you guys can do is actually, well, you're like, I don't know what my budget is, but what can I afford? Well, you can afford whatever we get here. I lied. It's after part B that we'll play around a bit. So 240 at 6. Yeah, I'm glad you guys are here. We're seeing that like the TVM solver, it's just a calculator. It's once we have the skills, we can do all kinds of problems. But you guys will be doing these kind of things next week for your performance test. So I'm glad you're getting trained on this right now. Okay, I'm ready to solve for PMT. I know exactly what I need. Did you guys get that too? 2,149.29. I can afford exactly that every month. It's going to last me exactly 20 years. Did you guys get that too? All right. 2,149.29. Yep. 2,149.29. You could take out 2,149.29. All right, so now you guys know how much to calculate or how to calculate what you need saved up to meet a monthly budget. You now also know how you can calculate what your budget is if you had a certain amount saved up. The last kind of question you guys need to be able to do is predict. So you know how much you have saved up. Graham, you with me here, Kendall? You know how much you have saved up. You know how much you want to withdraw. How long will your money last? So the last type of problem we're going to do is where you actually solve for N. How many withdrawals can you make? So same type of question. So we're using 6. We're going to use the same value as part A here. So we're going to use 300,000 again. And we're going to take out 10,000. The signs matter. We're gaining that 10,000, positive 10,000. FV is 0, 12, and 12. So let's calculate N. Obviously, we know it's going to be much less than 20 years. It'll be much less than 240. How much less? Let's find out. And keep in mind, this is not going to give us the years. It's going to give us the withdrawals, i.e. like the months here. And we will play around with this one in a second. So we're finding N, PMT, 10,000. And just resolve for N, 32.58. Did you guys get 32.58? Okay, so we won't worry too much about the 0.58. I'm actually going to encourage you guys just to round that up to 33, just as an estimate. I understand it's not quite 33. But let's just say 33. 33 withdrawals. That's 33 months. I think you guys could do some finger math. You might have to take off your socks too. But 33 months, that's not even 3 years. 36 months is 3 years. That's 2 years and 9 months. You could blow through your retirement savings, in this case anyway, by taking out 10 grand a year. Whereas if you only took out around that value of 2,000 and a bit, you can make it last 20 years. That's the third type of question that you guys should be able to do. Now, let's play around a bit. Everybody has just done that question. You guys should have these values stored in your calculator. What I'd like you guys to do, I'm just doing something myself just to make sure. Can you guys put in, let's do this. So let's head to our TVM solver. Let's go back and put in the 240. Let's go back to 20 years. So can you guys put in 240? Actually, forgive me. Putting in 240 is fine. We're going to change the PMT to something actually really low. Can you guys put in 1,200 for PMT? And yeah, please forgive me. Put in 1,200 for PMT. And we're going to solve for N. So I want you guys to put that in and then see what your TVM solver spits out when you do that. I really love everybody to do this one. You guys get an error? But I mean, isn't that kind of weird though? Like, it's not like all the signs are correct. We have $300,000. We're taking out $1,200 a month. Why is he giving us an error? Shouldn't our money last? Well, can you guys actually find out like what's 6% of? I'm just going to do this in the margins here. You guys this is just as an aside. We're all done the note. But what is 6% of 300,000? So it's 0.06 of 300,000. Like that's how much interest we make per year. I got 18,000. Did you guys get 18,000? We make $18,000 a year in interest. Well, how much is that per month? It's $1,500, right? That's $1,500 in interest every month. So if you're making $1,500 in interest every month, but you're only taking out $1,200, Are you ever going to run out of money? No, you'll never run out of money. So when we put in FV is equal to 0 and tried to solve for n, you guys got an error because FV will never be 0. Actually, our savings will continue to grow because we're only actually taking out $1,200 every month, and we're making that much more in interest. So really interesting. So the last thing we'll do, not a question on your sheet, what I'd like you guys to do, put in any number you want for n. I'm going to put back in 240. But what could we take out in order to live off of our interest forever? If you guys put in 300,000 for FV, but positive, we can figure that out. PV is minus $300,000. FV is $300,000, which just means at the start of our retirement, we have $300,000 in the bank. In 20 years, excuse me, we still have $300,000 because we're living off the interest. How much could you take out per month in order to just keep living off this interest? You guys can do those kind of questions too. Notice it gave us the $1,500 because that's the interest we make every month. This is called living off interest. This is another type of problem that you guys can do. And hopefully many of you guys get to that situation in your life where you can just be living off your savings and it will never run out. So wouldn't that be something? We have something to leave for the grandkids, et cetera, et cetera. So we did a lot of new types of problems today, even some interesting ones like this that you guys can have in the toolbox for next week. Anything you guys want to chat about? Otherwise, I have a one-page task for you guys to do with 30 minutes.